Good morning, good afternoon, or good evening, wherever you're logged in from. I'm Jackie Lynch, and in this session I'm going to talk to you about some advanced features within NIM, which is what this NIM 201 presentation is about. We're going to start with an introduction, talk about setup, talk about working with backups, go through some useful commands, and then we'll talk about nimadm and then using your NIM server with your VIO servers. And finally, we'll go have a few hints and tips that I'm hoping will be helpful to you. There's a lot of cool things you can do with NIM. It's more than just installing and maintaining systems. You can use it to back up and restore your AIX LPARs and VIO servers. You can use it to do your updates for both LPARs and VIO. You can use it for alternate disk copies and installs and cloning, migrations, and of course, once you become dependent on NIM, you may want to consider having an alternate master so that you do have redundancy. When you're setting up your NIM server, the most important thing to remember is it must be at the highest level of AIX you plan to support. So normally whenever a new level of AIX comes out, the first thing I do is update my NIM server. It should also use dedicated resources for the disk and network. A lot of people create a NIM LPAR that is dependent on the VIO servers. The problem with that is if the VIO servers go away, how are you supposed to restore the VIO servers from your NIM server? So I try to have my NIM server be its own LPAR with its one network card and one SAN card all of its own. That basically means that I should be able to recover anything. I always use scalable volume groups. I do create a separate file system called /NIM where all of my files for NIM end up going, and it's in its own volume group. And I normally have a separate file system /backups where my mksysb images go. That way I can export that without impacting my NIM. And here I have the list of file sets that you need to actually have installed in order to be able to use NIM. NIM does not like a dot in the resource names, so you need to use an underscore or just have everything run together. You normally would put the AIX DVD in the DVD drive, or you would load it somehow to the server so that you can boot from that DVD to install it. You may use an alternate NIM server to install the AIX. And then under your directories, you're going to end up with a number of subdirectories. LPP source, which is where the licensed program product source will end up. Images, which is where your backups will go. NIM SPOT, which is where your spots are going to go, and those are used for doing installations. And then there's a couple of other directories where you may save other types of files. And then I usually have a mksysb one where I may take an image from images and I may use NIM to migrate it and create a new mksysb image that I then install from. These are all things that you can do. So on my AIX 7.2 system, which at the time I started doing this was at 7.2.4.2, it's now at 7.2.5.2. These are some lists of the various file sets. So you can see my boss disk management NIM. You can see that I have a 451 gig /NIM. That's because I keep a lot of different images around. And then you can see down at the bottom of the slide the actual structure of my /NIM file system. So I happen to have put a whole bunch of ISO images there only because I didn't have disk space anywhere else. They don't normally live in NIM. But you would normally expect to see BOSINS data, images, LPP source, resolve conf and spot, and in my case I also have the additional mksysb directory. I always check my network setup, make sure that everything's in etc hosts. In order to add a machine to be supported by NIM, it has to be either in DNS or in /etc hosts on the NIM server. Then basically the IP must be resolvable. And then I make sure that in my inetd.conf I have both bootp and tftp available. Now for security reasons I usually keep those commented out, and it's only when I want to do something with NIM, like a restore or some kind of an activity, that I will uncomment them, refresh inetd, and then I can use them with NIM. If you're one of the people that uses TCP wrappers to wrap around your network services, you can't do that with bootp and tftp if you want NIM to work, so just keep that in mind. Also checking etc services that bootp is in there and that TFTP are in there, and normally they are by default. And you'll have to talk to your network security people if you're going across firewalls or routers to make sure that the BootP and TFTP protocols can pass through them. Otherwise, you'll have to have a NIM server in the same subnet behind the same routers and firewalls as whatever the LPAR is you're trying to recover. So one of the first things you want to do after you build your NIM server is you're going to need to create your LPPs and SPOTs, and this is the various line commands that I use to do that. And you'll see that I start out by creating an LPP source for my 7242. I then have a directory called add-ons, and that's where I put additional packages that I may need to have within my LPAR. And then I also have whatever the latest Java, SSH, and SSL file sets are, and I also put those into the LPP. That way, whenever I use the image that I'm going to create to do an install, it's going to make sure that I'm at the latest level. So after I build my LPPs, I then run a NIM-O check on the LPP, and then I create the spot from that LPP. So it's going to have installed in it everything that LPP had at the levels that I updated to. The next few slides are just showing you some of the resources. As you can see, I have a lot of different levels of LPPs and mksysbs and so on, because I support systems running all kinds of different levels of the operating system. I can get a list of just the machines, I can look at the groups, I can just get a list of all the mksysbs. There's a number of different things you can use with the ls-nim command. And you can also use the nim-o showres command to check if a particular file set is in your LPP. So as an example here, I am checking to see if BOS alt disk install boot images is in my LPP, and it is. I can also look for the Java levels and so on. If I do an ls on LPP source, you can see all the different LPPs that I have. I try to give them names that actually show what they are. Like LPP AIX 7242 is going to be AIX 7.2.4.2. And the same with my spots, I give them similar names. And if it's a VIO server, it'll normally have VIOS. So you can see down the bottom I have spot VIOS 312_21. That is for the VIO server level 3.1.2.21. And in my NIM images, that's where I copy mksysb images when I'm going to create a mksysb resource. I also use the lspv, the lsvg command, just to show you how many disks I have in my volume group and what the file systems are that are in there. I normally have a /software, which is all the software that I install everywhere, and that's NFS exported. I have a /backups that gets exported for mksysb, and then there's /nim itself, which I never do an export for because NIM doesn't like it when you do that. And /tftp boot is also part of that volume group. And this is just showing you sort of some of the sizes, so to give you a feel for how big my NIM environment is. Now again, I support a lot of systems and I have a lot of images that I keep track of. This slide is showing you the output from an ls-nim for a machine, and this machine AIX2 is an AIX system. It actually was running. I can also look at the LPPs with the -L flag, and what's nice about the -L flag when you're looking at a spot, it actually tells you what the OS level is. So in this case it's a 7252 spot, so I actually know that that's a spot, even though the name is 72TL5SP2. If I run the ls-nim-l, I can confirm that this really is a 7252 image that I'm going to be using. In this case, I'm just showing you what my VIOS images are. So you can see I have spots for every, and mksysbs for every VIOS back to 310 itself. Nowadays I'm installing 31221, and because it was announced this week, I'm probably about a week away from doing a test install with 3.1.3.10. So if I want to add a 72TL1SP1 resource, the first thing I'm going to do is I'll create the resources from the base CD, then I'll put the update CD in, and I'll update my LPP, and then I will go through and I'll update the SPOT. And I don't actually tend to use smitty to do it. I tend to use the actual commands where I do the nim-o define for the LPP, then I use the nim-o update to update that LPP, and then I do a define for the SPOT and build it from the LPP. So, and again I use the checks to check the SPOT and the LPP. If you end up assigning these resources to an LPAR and then not using them, sometimes it's not going to let you unallocate them. So the way to force that is using the nim-o reset. In order to set up a client to restore from a mksysb, first of all you have to make sure that the client name is resolvable. So that's either an Etsy host or a DNS. Then you're going to create it as a machine object to NIM, and that's done through administrative tasks, manage machines, define a machine. And when you do that, you'll put in the host name that it resolves to. You'll select the network type. You're going to have a 64-bit kernel, and the shell we use now is NIM-SH. We no longer use RSH. And depending on whether or not you're making any changes to that LPAR when you do the restore, you may or may not need to create an image data. Typically you'll see an image data used when people have a mirrored root VG when they did the mksysb, but when they do the restore, they want to restore it to a single disk. So that's something you can change in your image data file. And that's what this slide here is talking about. I can do things like change my logical volume policies. I can tell it not to shrink things. I can tell it to do an exact fit for the file systems or to basically match how they are. And then here's my LV data where I can put copies equals 1 or 2 or 3 and so on. By default, the image data file that is used is the one that is embedded in the mksysb image. But if you want to use what we call a side image data file, you can do that by creating one externally. And again, typical use is when you're going from a mirrored mksysb to a non-mirrored or vice versa. So after you've set up the machine and your image data, you've got to set up your mksysb as a resource. And that's done simply, I copy my mksysb image into /nim images, and then I define a mksysb resource, give it a name, and point it at the one that I created. So you do an ls-nim-l on your mksysb and grep mksysb, and it will show you the mksysbs. And you can actually look at the individual mksysb images, and it will tell you where the files are for them. To get more detail, you can see here that when I look at VIOS 31125, it actually shows as AIX 7.2.4.2. You also should check that the image that it has listed under location is actually in that location. Make sure you did actually move it there. So in this case here, we're now telling the AIX2 machine that it's going to do a mksysb install. I usually select the SPOT, the mksysb, and the LPP just in case there is something missing in the mksysb. And yes to accept licenses, but I always tell it not to initiate now. I prefer to boot the client into SMS mode and initiate it from there. I don't like to do a push, which is where I basically tell the client to do the install now. So it's personal taste. I just happen to prefer to do it as a pull. And here you can see the commands if you want to allocate the SPOT or the LPP source, and the command to tell it to do the NIM boss inst, or you can do the whole thing through smitty. Either way works. This is what it looks like in smitty when you're doing a NIM boss inst and the various fields that you fill in. And you can see about halfway down I have the force push the installation, and I have it set to no. These are kind of like what the defaults look like. So go through those and make sure that they are what you want before you click on OK. Right, so this is just showing you the output of the ls-nim, showing that we're ready for a NIM operation, but we are currently running. We check with the show mount -E and we make sure that the images, LPP, source and spot are actually exported to that system. We check the bottom of boot P tab to make sure that that system is showing there. And we look, in this case I was looking in TFTP boot and looking for ones that labeled BIOS, but I would normally be looking for the 72 TL01 SP2. So just be aware that if you don't see them in TFTP boot matching up with what you see in the show mount -E, then you're going to have a problem. There's a number of useful NIM commands. Occasionally, it's very rare, but occasionally an LPP ends up with no simages flag, and that simages flag is what is needed to make a bootable image. So if you find that, and you can tell it when you do the ls-nim, then you need to run this NIM update with recovery equals yes, point it at the source for the base, and it will actually take the LPP and make sure that there is an simages. I haven't seen that flag missing for many, many years, but it's a little trick that's useful to know about. I already talked about allocating and deallocating resources, and like I said, you can do that using the nim-o commands, or you can do those through smitty. And then I have a couple of examples down here for doing updates to add packages, and the second one is actually how to remove something. So it's a nim-o update -a rm_images equals yes. That says we're going to be removing images. This is what I'm removing, vos.games, and I'm taking it out of LPP source 1. I also want to point you to the alt_root_vg_op command. That is the command that we tend to use now rather than things like export and import, so you should make sure you become very familiar with that command. Now sometimes you set up a machine to be installed and you change your mind and don't want to do it. So if you have it enabled for install, you can change it all through smitty, or you can basically do a nim-o reset on that client and then a nim-o deallocate to deallocate all the resources. Another thing to keep in mind is if you use LPM a lot and you also use NIM, you may need to update the CPU ID for the client. So if that becomes an issue, you use this nim-o change -a CPU ID command. Now, when you're doing an install, there's a few things that you need to be aware of. Typically, you can't install a VIO server from an HMC or from NIM if the network is aggregated. And by the way, that applies to any LPAR that is using aggregation. Now, there's a couple of ways around it. There is a way when you do the SMS boot where you can try and tell it that it's using an aggregated link. That may or may not work. What a lot of people do is they'll have a separate admin network. So they'll have a 1 gig network on a single port that's just used for installs. Normally when I'm building something like a VIO server, I simply have them build it for me with access ports, and then after I get it installed, I just get them to switch it over. But you can certainly see if you could do the SMS boot over an aggregate. I have not had great luck. When you're installing on SanDisks, they're going to need you to light up the adapters so they can do their zoning and mapping. If you're using NPIV, then in the HMC you can just go to the profile, go to the virtual adapters and light them all up using the log-in, log-out fiber. If you're actually using real adapters, so you need the WWNs for the actual physical adapter, those are the ones that start with a 10 or a 20, then you're going to have to boot in SMS mode, and that may or may not give you what you need. Also, you'll find sometimes that you'll get LED hangs with NIM. It's very rare, but it still does happen. So I have a link here for you on how to troubleshoot those if you have them. I'm not going to go into it in great detail, but I do want to mention that for some time now, IBM has been recommending switching from STD PCM to AIX PCM. There's a new MPIO best practices document, and then there's some other links down here on migrating to AIX PCM and on MPIO resiliency and so on. So we've built all our resources. We're now going to start the install from the client. So we go into SMS mode and we go into set up remote IPL, and here we go through and we set up all our IP, etc. And if you look down here where I have the select to for adapter config, the protocol I have set to is standard. That's the point at which you can actually switch that to be aggregated and see if you can get that to work. And then you do a ping test, and if the ping test is successful, you go back to the main menu and you're going to select your boot device, which will be the network, and you're basically going to tell it to boot from whatever the Ethernet connection is that you actually have set up for the Ethernet at the very top. For your next steps, the LPAR server is going to boot, and you should see TFTP startup. It's going to be anywhere between 30,000 and I've seen it as high as 60,000 packets. Sometimes it goes through that TFTP process twice, and you should get a console prompt. You hit F1 if it's the first time to boot and enter the console. I usually choose English. And you may get the message about all logical volumes are being created exactly as they were, but the disks are not the same. And that could be because you've got a slightly larger disk or there's a change in the disk type. Don't worry about that unless you know something, which means that you should worry about it. Just choose one to continue the install. And then I always check my install settings, and I make sure that the disk that I chose is the disk that I want to be chosen. Sometimes I'll have a couple of 100 gig disks and a bunch of 400 or 500 gig disks. I want to make sure that whichever disk it chooses, which in this case is H.0, is actually the one that I want my root VG on. And I always tell it not to import the volume groups because I'm doing a restore of my root VG. I don't want it to import any other volume groups till I'm sure that I've actually brought the system up. If the mksysb is mirrored, then you're going to need to provide 2 disks to restore to unless you use that side image data file. Once the system's rebooted, you check everything, you can import any volume groups, you can remirror root VG, and you can go ahead and do any other tailoring that you would normally use. So after the reboot, the install is going to start. You can monitor it using ls-nim-l LPAR name. You could be logged onto the HMC using VT menu and monitor the boot during the console. And you can also monitor the reference codes on the HMC. And if you want, you can do all 3. Here I've listed a bunch of useful commands for NIM, just so that you have those in one place. And again, these are the ones that I usually typically issue on the master. So here I'm looking at my mksysbs for the VIO server. Additionally, you want to keep an eye on this niminfo file. Each client will have an etc niminfo file, and your master will have a /etc/niminfo file. This is where it just determines which ports it's going to use for NIM. And that's useful to know because if you have an issue with your firewall, you may need to change the master and registration port for the master and the clients in order to have NIM working. In my case, I have not had to change them from the defaults, but there are instances where you may have to do that due to firewalls. Additionally, there's this thing called the NIM database, and really the NIM database consists of /etc/niminfo and everything in etc obj NIM. So here you can see there's a bunch of different attribute and object files. And if you have to look at the NIM logs, those all live in /var/adm/ras. And you can look at them using the alog command. It will show you any failed NIM operations if you look at the NIM log itself, which is called NIMlog. I mentioned the database. The way that we back up and restore NIM is we basically save the following files to a different system. So I would take a copy of etc niminfo and then the etc obj/nim star files. And the way that I restore it is I basically can copy those files back in. If I have to recover /etc/niminfo and I have running NIM clients, I can rebuild it using the nim config command. I can also rebuild it from a running NIM client by using nim init and pointing to the actual client. And one other thing that you might want to check is whether or not NIM is actually starting on your master, and you should expect to see it in /etc/init tab with a line that does a start source -gnim. So this is an example of /etc/niminfo on my client, and again you can see there's a master and a registration port, and then there's a number of different settings through here that are going to be set up, and one of the ones you want to check is under export NIM hosts. I always check to make sure that the IP for my client and the IP for my NIM server are actually correct. Now when you're using NIM, you can use NIM to do migrations and updates. A migration is where the version or the release gets changed. With an update, you're preserving the version and release. So we're basically talking for an update, it's a technology level or a service pack, but a migration is used for versions. Both options can use alternate copies of rootvg as long as you have a second disk available to you. And then it will put all the changes on the alternate disk, and after the changes you can boot from that alternate disk and you can test it. Whenever new LPP sources and SPOT, whenever new AIX versions come out, you have to do the NIM Master first. So I always do my update to my NIM Master, make sure I'm happy with that, and then I can create the new LPP source and SPOT, and I can then move forward with my client LPARs or VIO servers. If I'm doing migrations, I will use nimadm. I also use nimadm to install down-level mksysbs and migrate them. So for instance, if I have a mksysb at a level that's not supported, I can take that mksysb and I can migrate it and create a brand new mksysb image, and then I can use the new mksysb image to do the restore on the new server. I can also do things like NIM clone with update all to update a TL or SP. I can also use MULTIBOS, which I'm not particularly a fan of because it gives me multiple copies of AIX on the same physical disk, and I just find that too confusing. I prefer to have them on separate disks, but that's a personal choice thing. Now, in terms of backups, I have /NIM as its own file system, and I have a completely separate file system that is called /backups on NIM and is mounted on all my clients as /user local backups. What I will do is all my clients take mksysbs to the NFS mount, and then if I want to use that mksysb for a restore, I copy it to /NIM images on the master, and I create a mksysb resource for it. The reason for having /backups be completely different is that NIM does not like you doing any exports for anything in the NIM subdirectory. You can get around that by using the NIM mksysb subdes equals yes environment variable. I just find it simpler to keep my mksysbs and other file systems that I want to export from my NIM server separate to my actual NIM environment. So nimadm stands for Network Install Manager Alternate Disk Migration. And this is the one that lets me take a copy of my rootvg. It lets me create new NIM mksysb resources from it. It allows me to do migrations and all those kinds of things. So the main thing I have used it for is when I have an image that I need to do a mksysb update to. So what I will do is I'll take that mksysb image, I'll put it into smitty nimadm, and I will actually upgrade it to whatever the level is I need to upgrade it to and create a brand new mksysb image. So at no point have I touched the actual production system. Then I can restore that mksysb image to an alternate disk, and I now have an upgraded copy of that operating system, and I can boot it at my leisure. And there are very good man pages on using nimadm. So nimadm requires that boss-alt disk install.rt is installed into your SPOT. So if you're doing this on the client itself, then you need to put it there. And basically in this example here, I was taking an AIX61 image and I was exporting it to an AIX71 image by pointing it at the SPOT and TL for AIX71. And I was calling the new version CGAIX71. And down here I've got all the flags that tell you, what they should be doing. I can also add a -D space HDisk3 telling it to not only create that mksysb image, but please write it out to a specific HDisk, which is going to be your alternate disk. So it's actually a very, very powerful command. Now, whenever I'm planning on doing some kind of a maintenance activity, I tend to take a copy of my root volume group. So I will use the alt disk copy command to basically clone my rootvg to another disk. In this case, my rootvg is currently running on HDisk 0, and my free disk to copy to is HDisk 2. So the alt disk copy command, I use the -V flag that tells it to run in verbose mode and tell me everything that's happening. -B stops it changing the boot list. I don't normally let it change the boot list because I want it to stay where it is until I am ready to change my boot list. And then the -D HDisk2 tells it what disk to actually target for the output. I always run a BOS boot -A-D on the current disk. I want to make sure I have a valid boot image. And then I run my boot list, check where it's set to. When I'm ready to go to the new updated copy, I'll change it with a boot list -M normal HDisk2, and then I'll check that it changed it. Under the covers, when you do a version 3 upgrade of your VIO server, IBM uses this type of direction. Now, if I'm doing an update within the same version or release, I can just do straight out cloning. So I build my LPP source, and I'll update my NIM Master and reboot it. Once my NIM Master is at the right level, then on my client, I'm going to make sure I have a spare disk, which means if I've got a mirrored root VG, I need to unmirror it. And then I'm going to use smitty alt clone from the master to specify the client and the target disks and tell it to do an update all and point it to the LPP source. And of course accept the licenses. And then what will happen is the client will be running on root VG, but the actual update will be done to the alternate disk, and then afterwards you have the option to boot from the alternate disk and test it. And if it doesn't work, then you basically set the boot list back to the old root VG and you're good to go. I mentioned MULTIBOS earlier, and MULTIBOS is the ability to have multiple versions of the operating system on a root VG. The reason that people do that is because they're using internal disks and they may have gotten, for instance, 600 gig disks, and root VG is only taken up 100 gig, so let's have a couple of them on the same system. The problem with doing that for me is I just get confused about which instance is which, so I prefer to do it using separate disks. But again, it's one of those things that's personal choice. So alternate disk install I use all the time. And that's basically what's happening when I'm doing the alt disk copy, smitty alt clone. I'm using those to set it up so that I can do an alternate disk installation where all my upgrades go onto a separate disk. And then we reboot from that disk. So I have a link up here to the alt disk clone instructions. So the 4 commands that you should become familiar with doing the man pages are alt disk copy, alt disk install, alt disk mksysb, and alt root vg op. So this is an example where I'm installing a mksysb on an alternate disk. When I do my LSPV, you can see that HDisk 0 is what I'm running on and HDisk 1 is empty. Now you may also, if you're at a high enough level, want to use the MPIO command to check that the size of the disks is the same or HDisk 1 is bigger. Make sure that you've got the alternate disk install boot images and alt disk install RTE installed, and then you can move forward with doing what you want to do. So here I'm telling it that my target disk is HDisk 1. The image that I'm restoring from is /user local backups, and I'm pointing it at a particular mksysb. I can point it at an image data file if I want to. You can see here I'm telling it not to set the boot list and not to reboot, and that I want verbose output. You can then see that it goes and creates a whole lot of logical volumes, all with the word alt underneath in front of them. And so it'll create alt inst root VG, create all these logical volumes with these names, and then at the very end it renames them and turns the volume group off. And it goes through quite a few things in restoring the mksysb images. At the end, what you'll see is you have root VG, and now HDisk 1 is set to alt inst underscore root VG. And this is where you check your boot list just to make sure that it is still booting from root VG. So there are actually 3 different phases that this all goes through. The first step's where it creates the volume group, creates the alt logical volumes and the file systems, and does the restore. Then the second phase is where it runs any specified customization scripts. It puts on any updates or file sets and copies files as necessary. And the final phase, phase 3, is where it unmounts those alt-inst file systems, renames them in the logical volumes, and updates the ODMs and varies it off. And then if you allow it to, it will reset the boot list and reboot. So while the actual clone was running, I was running an lspv-l just to show you all the different file systems that showed up on that disk. As soon as the clone is finished and the update's finished, you're not going to be able to see these anymore because the disk will actually be buried up. So after you've created your alt-inst root VG, let's say somebody changes something in Etsy file systems or Etsy hosts, and you need to change it before you do the reboot. You can actually use alt-root VG op or alt disk install -W to wake up the volume group. And it will actually wake it up. It will remount all those file systems as /alt_inst/ whatever. You can then go into /alt_inst/etc/hosts, make the change to Etsy hosts, save it, and then you can use the -S to put it back to sleep. That allows you to make all the changes that you need to make if you need to make a change before you boot from the new image. And this is just showing you a df-g output when I actually had the alternate install running, just to show you the different file systems. And actually, you can actually monitor how far it's gone through the copy, etc., by using the df-g and comparing, alt-inst home to /home to see if they're the same size yet. One of the things you can do with alt disk copy is you can actually do kind of an update on the fly. So in this particular case, I'm doing an alt disk copy. The target disk is HDisk1, and my current root VG is actually 7100, but I actually want to go to 01. So I'm actually I'm using my current root VG to take the clone from, writing it to HDisk1, and then I am updating it from my 710001, and that's going to come out of /updates. So it will actually update it to 7100-01. Now it will set the boot list unless you use the -B, so be very careful. It's kind of a cool thing because you can copy the running system and put on maintenance in one step. Also keep in mind that the old root VG that you were booted on initially, after you do the reboot from the new disk, it renames the old root VG to old_root VG. And you can still go back to it if you need to. So if I have to upgrade a 7.1 system to 7.2, the way that I would do it is I take a mksysb on the client, and then I always like to check in that mksysb that certain things got copied because there were a few bugs early on. I then use nimadm to do my conversion. So here I'm taking that mksysb that I took just up the top, and I'm writing it out to a different name in a different directory. And I'm using the 7212 SPOT and LPP to do the actual update. So it will take all the file sets that it needs out of there, and it will update that mksysb image to 7.2. I then have the ability from the master to actually use alt disk mksysb to actually do the installation to the alternate disk, and then I can boot from the alternate disk. The most important thing that I found when I had problems was that my etc inetd.conf and my etc init tab have to be clean. We had a problem where there was a line in inetd.conf that somehow got split over 2 lines, and it was actually causing the converted mksysb to literally drop well over 2,000 file sets. And then the last tip is, when you're doing this, because nimadm does set the boot list, make sure that you set it back if you don't plan to boot that migrated image immediately. So I showed you the listvgbackup command before. It's actually very useful because what it lets you do is search for any file set or file name within a particular mksysb image. So if you want to double check that something's in there because you can't remember if you added it, you can actually do the listvgbackup command, point it at the mksysb, and do a grep on whatever it is you're looking for. Now when you're working with the VIO server and NIM, one of the things that you'll need to do for your version 3 upgrade is you'll have to extract the mksysb image from the VIO installation ISO. If you're using the 2 DVD set, you have to go through a procedure where you get all 3 mksysb images and you concatenate them. I use the flash ISO image because it's a single mksysb image to deal with. So I take that, I mount that ISO, I take that image from there and I copy that mksysb into my /nim/images directory and I give it a meaningful name. So here you can see I did the VIOS 31125 flash mksysb image. And I then define that as a mksysb resource. Now I can build a spot from that mksysb. And when you're working with VIO servers, the spot should always be built from the mksysb. There is no LPP, and you never ever point anything to do with the VIO servers towards the base install file sets. So this is the correct order. Build the mksysb image, and then build the spot for your VIO servers from the mksysb image. And then you can check those images. So here we're checking them. We're running an ls/nim on the mksysb. And it's coming back, and this is a more recent one for spot VIOS 312.21, and as you can see it's coming back as AIX 7252, which is what it should be coming back as. So after checking the mksysb resource, we now check the spot resource. It too shows as a 7252, and it's actually showing that its mksysb source is the mksysb that we were just looking at. So those both match, so I feel comfortable that these are now usable. You can take advantage of NIM to back up, install and update your VIO servers. I have all my VIO servers set up to take mksysbs automatically to my NIM server. And I use the NIM server to restore them when I have to. So I always create my spot from the VIO server mksysb image, and then I basically take care of using NIM to update, restore, etc. and maintain my VIO server. You can use the nim-o updateios command or the nim-o alt disk install command for working with VIO servers. If it's an update within a version, it is updateios. If it is an upgrade, as an example from version 2 to version 3, you must use the upgrade VIOS command. There is a difference between an update and an upgrade. Upgrades are when you go from one version to another. So we add the VIO server partition as a client, we create our mksysb image, we define that resource, we define the spot. I typically copy the bosinst.data from the VIO server DVD and I create a VIO server bosinst resource. And then when I want to do a mksysb install, I use bosinst to do so. This is an example of the man page from the nim-o updateios. Just be aware that there is an updateios command and an upgrade VIOS command on the VIO server. And there is also the same things on the NIM server, and their syntax is different. So whatever else you do, you should actually pick one methodology to do things and stick with it. It will make your life a lot easier. Now the NIM VIOS upgrade, as I said, is a little different to the one on the VIO server, but it's basically used to do a bosinst upgrade. So from the NIM server, I can actually tell it to upgrade the VIO server from version 2 to version 3 on an alternate disk. And I've got some examples here from the man page on the NIM version of VIOS upgrade, just so that you can see some of the flags. So there's a couple of different backups that you can do for your VIO server. The first one is just a standard backup iOS, and the second one is a backup iOS -mksysb. The first option creates a version of the backup which ends up being a NIM Resources tar file that you need if you want to do a restore from your HMC. The second one creates a proper mksysb image you can use to do a restore. Keep in mind that whenever you go to do a backup, you should also use viosbr to back up all your virtual definitions, because the mksysb doesn't really back those up or recover them. So a typical step would be viosbr, mksysb, and then restore, viosbr to restore them. This is a typical backup script that I throw into crontab. You'll notice that I unmount /var/vio/vm library. Even though I'm specifying -no media lib, I've had instances where it's tried to back up the media library as well. and since my media library tends to be rather large, I don't really want it backed up as part of my mksysb. So I unmount it before the backup, run my backups, and I run both kinds of backups. This first backup is the one that creates the NIM Resources tar file, and the second backup is my proper mksysb. And I run this script on my VIO servers at least once a month. And of course, that requires that I have an NFS mount of /user local backups. So, keep that in mind that you're going to need that. And of course, you do need to take an HMC scanner report or some kind of assist plan just as part of your documentation and backup strategy. This is an example of running a backup to create the NIM Resources tar file. And basically it goes and tells you it's going to back up 15 files, it does a save VG, etc. And then when I do my LS, you can see a very large NIM Resources tar file. In this case, it was about 21 gig. But during the process, because it was expanding and contracting things, I needed as much as 40 gig for that backup in the file system. You can actually restore from that file to a specific disk, and this is an example of some of the things that you'd want to do that. But I would definitely check the documentation to make sure that you are doing it correctly. So the first step is changing your BOSINS data, and then you use the install iOS command from the HMC, and you point it at that tar file and give it all the information it needs. And then once it's done the restore and the system's rebooted, you're going to need to go and use your VIO-SPR to restore your virtual devices. The other option is to use your NIM with that proper full-blown mksysb image. And that's basically a standard NIM restore, where you set up NIM to do a smitty BOSINS for the mksysb restore the same way that you normally would for any other kind of restore. In my case, I basically do a pull from SMS, but you can actually do it as a push as well. It's up to you. And IBM has this document called backupios_mod.pdf that goes into this in a lot of detail. If you need to uninstall NIM, it's basically a nim-o unconfig master, and then you uninstall boss.sysmanagement.nim.master. But you have to unconfigure it before you can uninstall that master file set. I sort of touched on this earlier, but you should never do any kind of an NFS export to your /NIM file system. NIM does that when it needs to, and it gets very upset if it's already exported by somebody else. So one of the things that you want to do is make sure that anything within your NIM environment that you want to export to other places is either in a separate local file system that you can export without NIM caring, or you can change the NIM restriction on NFS exports. It's entirely up to you. I tend to keep things like backups and software in their own file systems outside of my NIM so that I don't have that problem. And then if you want to have a silent install from NIM, you could basically use the show progress equals no, and you're not going to get all those lines. I personally run it in verbose mode because I like to know what NIM is actually doing. The other thing you may want to do if NIM is pretty critical to you, or if you have to have NIM under the control of a VIO server, then what you could do is on one server have a NIM server, and on the another server have an alternate NIM master. That way, if you have to recover the VIO servers, you could kind of do it on a cross method. So if you have a NIM master, you can actually use smitty nim int alt master and actually tell it to set up an alternate master and to keep it synchronized. And then you can regularly tell it to sync or replicate, and you can have it rebuild NIM clients and so on. So you have a number of different options for creating a NIM master that is an alternative in case you lose the primary. So don't forget to do that if you do have to have virtualized resources such as your I/O or your network in your NIM server. As I said, I tend to give them their own dedicated fiber card and their own dedicated network card, but if you can't do that, then setting up an alternate NIM is a good idea. You're likely to strike some problems with NIM, as in bootp not working or TFTP not working. The favorite one that I used to get a lot was an LED 608, which was a bootp or TFTP problem. This slide talks through some of the things that you should be checking to make sure that you don't have an issue. And if you are still getting an issue after that, then you're probably going to have to talk to your network team to find out whether or not they're blocking things through the routers or through the firewalls. I hope you found this useful. And if you have any questions, please don't hesitate to reach out to me. I've got both my email addresses there. I'll also be uploading a copy of this presentation to my website, although it will be available at the PTechU site. I hope you enjoy the rest of the conference, and thank you for listening.